This video is about bearings. True bearings are measured clockwise from due north, so that's this way. True bearings are written using 3 digits, as you can see in this example. This example shows some of the standard or typical bearings that you can come across, such as north, northeast, east, southeast, etc. You'll use your knowledge of these standard bearings to find other unknown bearings. This is an example. Find the true bearing of the following angle. What do we know? We know that the true bearing of true south is 180 degrees. That means we can find this true bearing, which is this angle here, by going 180 and subtracting this 20 degrees here. 180 minus 20 is going to give us an angle of 160 degrees, and then we'll write a capital T for true. That's all. Now let's do a more challenging worded problem that involves trigonometry and bearings. We'll start off by drawing a diagram. In a diagram with bearings, we draw a compass at each change of direction. So I'm going to start off with a compass here and indicate that this is north. A ship travels due south for 3 kilometers. So if we're starting here, we're going to travel due south for 3 kilometers. Then we've changed direction, so I'm going to draw a new compass down here. And we've traveled 130 degrees for 5 kilometers. So 130 degrees is going to be down here somewhere. And we've done that for 5 kilometers. Just going to indicate that this is 130 degrees. Right, now I'm going to finish this diagram by drawing a right angle triangle at this point here where I'm interested in. I'm going to indicate this angle inside the triangle as theta. And I'm going to label this as x and this as z. These are just variables I've chosen to represent the unknown sides. Let's have a look at what the question is now asking us. How far east is the ship from its starting point? So that's this x value here. The first thing we need to do is find the value of theta. So theta is going to be this 130 degrees true, but we're going to subtract 90 degrees, which is this section here. So theta equals 130 minus 90, and that's going to give us 40 degrees. So I'm just going to indicate that this angle in here is 40 degrees. Now we're going to label our sides as we normally do in trigonometry problems. We've got our hypotenuse, we have our opposite, and we have our adjacent side. We're interested in the adjacent and hypotenuse. So that means we're going to use cos theta. Now our theta is 40 degrees, and that equals adjacent, which is x, over hypotenuse, which is 5. Rearranging this equation, we're going to say that x equals 5 times the cosine of 40. Typing that into the calculator, we get that x equals 3.83 kilometers. That is our first question complete. The second question is asking us, how far south is the ship from its starting point? So that means we're going to need to find this side here, so the z side, and we're going to add it to this 3 kilometers to get our total distance south from the starting point, which is up here. Now, there are a couple of ways we could find the value for z. We could use trigonometry again, but we could also use Pythagoras theorem, which is what I'm going to do. So I'm going to change my color and just go down a little bit. And so we know in Pythagoras that our b squared equals c squared minus a squared. So this is what we've called z equals our c, which is going to be 5, the hypotenuse, minus x, which we now know is 3.83 all squared. Go down a little bit further. So our value for z equals the square root of 5 squared minus 3.83 squared. And if you type that into the calculator, you'll get 3.21. Now we still need to add this to the 3 kilometers that the ship originally traveled south. So our final answer is going to be 6.21 kilometers. So that is now our answer for part B, and this question is complete. Here are just a couple of tips for solving problems with bearings. First, you need to draw a clear diagram labeling all relevant angles and lengths provided in the question. Then you need to draw a compass at each change of direction, as I did in the previous example. And you need to clearly show a right angle triangle, which will help you solve the problem using trigonometric ratios.